You are listening to the Information Security and OSINT podcast, episode 8, originally released on May 22nd, 2020. My name is Josh Amishav. This week we'll do a deep dive episode focusing on mapping out a target's attack surface using Amass. Amass is a great OWASP project led by Jeff Foley. I use it almost every day for DNS enumeration and network mapping. Direct support for this podcast comes from BreachSense, the data breach monitoring platform. You know the easiest way hackers break into your network? By using valid usernames and passwords. Attackers collect millions of leaked credentials from almost daily data breaches, but without having any visibility into which of your employees or users' credentials have been leaked, it's tough to protect against this. Integrate BreachSense's powerful yet easy-to-use API into your existing security solutions to prevent account takeover and stop online fraud. A couple years ago, I remember talking to a DevOps manager about asset management. I told him that I was developing some code to help organizations track their online assets. At that time, he couldn't understand the need. His response was that companies already know what they own, and if they didn't, they would just set up a network sniffer in their internal network and at the gateway to see who they were communicating with. Now, judging by the number of startups in the space today, I think it's safe to say that the industry has matured as a whole, and we now understand that most organizations don't have a handle on what and where their assets are. And without being able to enumerate what you own, you can't protect your online assets. Amass is a tool that helps us figure out what assets a company owns. It's great for mapping out the attack surface during a pen test engagement, and for bug bounty hunters is a must-have in their arsenal, particularly the tracking function to find new assets as they spring up. Normally in an engagement, you get a list of domain names or network range, and sometimes you just get a company name, or perhaps for a really large target, you would get a AS number. The first step in any pen test is to enumerate your targets. Now, let's use Tesla as an example. They have a very liberal bug bounty scope. Basically, they include everything they own. Previously, we talked about using Hurricane Electric as the starting point, and I still recommend this approach. You can browse to bgp.he.net and query Tesla and get a list of ASNs that include Tesla in the name. Hurricane Electric returns 6 ASNs, but as you can see, there are several variations of the name Tesla in the description. Some of them belong to Tesla Motors and some do not. So before going any further in our enumeration, we need to make sure we're mapping out the correct targets. Now, Amass has a ASN feature as well. You can run Amass intel -org Tesla, that query returns 3 ASNs, but only one of them overlaps with Hurricane Electric's results. But based on the names, it's clear that 2 of them don't belong to Tesla Motors. Thus, I still think using Hurricane Electric's ASN lookup is the best starting point. Now, at this point, we can use the Intel subcommand to feed the ASNs into Amass, which looks up the associated network ranges and uses that to find domain names. Now, let's take a step back for a moment. Amass supports 5 different subcommands. Intel for discovering new domains. Enum performs enumeration and network mapping. Track tracks the changes between enumeration scans. Viz builds a visual graph of the results using D3 by default, but also supports Graphistry and Multigo as well. And DB lets you query the historic scans you've run, which are stored in a graph database. I should also add, in addition to figuring out the ASNs and network ranges used by the target, if the company has recently acquired another company, and like in the case of Tesla's bug bounty program, those are in scope as well, we can add those in. You can go to Crunchbase, search for Tesla, and then click on Acquisitions, and see they acquired Deepscale and Maxwell Technologies last year, and then add their assets back in. Now back to the Intel subcommand. You can give Amass a IP address, a CIDR range, an ASN number, as well as a port number to scan. And you can also use my personal favorite parameter, the whois flag, which runs a reverse whois query to find other related domains. Now let's give some examples. Using the 3 ASNs we enumerated from Hurricane Electric, we can feed those into Amass via a command like Amass intel -ASN 394161, which we got from the Hurricane Electric scan, and that looks up the network addresses associated with that ASN, then enumerates the domains sitting in those ranges. I should note that Amass supports sending multiple ASNs in a single command by separating them with a comma. However, I recommend using a bash for loop to submit each ASN separately to Amass, otherwise it sometimes gets stuck. Using this technique, we can start enumerating other domains like Zaire.com that sit in a ASM belonging to Tesla, and if we didn't do the scan, we wouldn't have known that the two are related. For smaller targets that don't have an ASN, you can use the CIDR flag instead and feed it a network range. And I'll put some example Amass commands in the show notes for reference. You can also give Amass a network range and a port like 443 and 8443, and it'll parse out any domain names it finds in SSL certificates in the target range. Personally, I prefer to use the Python SSL scrape script for this instead. Another technique I like to use to find related domains is the reverse whois lookup. When you buy a domain and don't enable privacy controls, there's a registrant email address associated with the domain. We can use this to find related domains. For example, we can query all the domains registered that used a tesla.com email address during the registration. While this is a great technique for finding related top-level domains, it may also include personal domains employees registered using the work email account. So before adding these to your scope, make sure they're relevant. Now, the nice thing about Amass is that it's self-feeding, meaning every new asset it finds, like a domain name, it is fed back into the system for further enumeration. The results are stored in a graph database, which can be queried afterwards as well. This also means that if your enumeration is taking too long and you kill it, your findings are stored in the database. The next time you run Amass, it already has the findings from your previous scan and will get fed back into the scanner. Let's talk about the track subcommand next. It can be very helpful for bug bounty hunters and consultants running a monitoring service. You can run weekly or monthly Amass scans, then have it compare its results to the previous scans and only show you what's changed. You simply run Amass track -d and the domain you want to show changes for, and this will show you new assets that have popped up as well as network changes. In terms of visualization, you can use the viz subcommand to generate a D3 HTML representation of the data. If you have a lot of data that needs mapping, then you're probably better off using the graphistry flag. You can also export the data into a Multigo CSV file. As with all the subcommands, there are a lot of command line options available, which you can see via the -help command. For example, amass enum -help shows all the enum subcommand parameters it accepts. I should also note, if you use a lot of parameters, it's probably cleaner to put them in a configuration file instead. Amass pulls data from a lot of sources, which you can see by running the -list parameter. If you run an enumeration scan via something like amass enum -passive -d tesla, then Amass will query the list of sources shown from the list command, but won't do any active scans like DNS brute forcing. And on the topic of DNS brute forcing, some DNS servers resolve arbitrary non-existing domains which will screw up your findings, meaning the DNS server will return an IP for idon'texist.acme.org, even though there's no such subdomain. This is something that you probably hid if you run mass DNS. Amass, on the other hand, checks for this and accommodates accordingly. The most popular subcommand is enum to enumerate subdomains. While Amass comes with a word list, it's limited and you probably want to use one of your own. There are lots of lists out there. I'll especially mention the seclist GitHub repository as well as Jason Haddock's word list gist, which are very helpful. So to run a brute force DNS enumeration scan, I like to use amass enum -d tesla -brute -src -ip -active -o and the name of the output file, and then the word list. So let's just break that up. The -d is for the target domain name. -src displays where Amass found the asset, so if it found it from querying cert.sh or via running alterations or brute forcing, it tells you how it found it. -p resolves the domain to an IP address. -active attempts to run a zone transfer and parses out certificate names as well. And the -o tells Amass where to store the output. Amass runs alterations and permutations on domain names. For example, if it finds a server named prod01, it will check for prod02 up to prod99. The alterations done are configurable, so you have a lot of control over the various permutations used. And this should be done in a configuration file. Once you have the list of domain names, I like to pipe those through HTTP probe to figure out, and that's a separate Go project, to figure out which of those domains are actually web apps, and then use something like web screenshot to pipe the list of domains through web screenshot to take a screenshot of the web root for those domains, which helps me figure out where to focus my efforts. Now, I've tried Eyewitness and Aquatone in the past for the screenshots, but haven't had great results. What I like about web screenshot is that it does one thing and one thing really well. Now, after I figure out what web apps are in scope, I'll run ff, which is sort of like GoBuster for directory enumeration. Maybe we'll cover that in a future episode. After you run an intel or enum scan, you can always use the db subcommand to see previous enumerations you run. You can run amass db -list to see the number associated with a particular scan, and then you run amass db -enum, and the number like 1 or whatever, and then -show to show the enumerations found for that scan. In addition to the list of domain names found, Amass also gives you a table listing the IP ranges the assets were found in, as well as the number of assets found in each range. And this is very handy to figure out where to focus your efforts to find other assets, meaning if there are 17 domains sitting in a Class C, odds are there may be other interesting services there as well. In addition to figuring out which web apps can be attacked, you should run mass scan against the target ranges as well. Once you know which IPs have services running, you can feed those into Nmap for deeper scanning like service enumeration and NSC scripting. So let's summarize. Amass is a great tool to enumerate the attack surface for a domain. You can use it to find related top-level domains, brute force subdomains, as well as map out network ranges your target uses. That's it for today. If you have any feedback or questions, please contact me at podcast@breachsense.io. And if you got value from this episode, then please share with a friend. See y'all next week.